Section 2.5, Reasoning Using Properties from Algebra. We are going to be starting proving and justifying using properties that we have from algebra. And we're going to start with using like those properties while we solve some equations. So if you were asked to solve this equation, okay, you would be using the distributive property, 14x minus 4 equals 3x plus 7. You probably just do this naturally now because you've been doing it for so many years. You don't really even think about that what properties you're using that allow you to do these steps. This would be 11x. So now we are going to add 4 to each side, and you get 11x equals 11. So dividing x equals 1. Okay, and we can do it for equations where we're solving for a variable as well. But we're going to just go on to the properties that we just used. I mentioned one of them, the distributive property. That's very common. But there were a lot of other properties that we used in that problem. So let's start taking a look at these properties. The big key here is all of these properties start out with if A equals B, then. So if A equals B, then what we have is A and B, but if we go ahead and add A plus C, if we add equal amounts to each side, then we still have a balanced equation. That is actually called the addition property of equality. Okay, we'll just call it the addition property, and that's fine. So similarly, the subtraction property of equality says, hey, if A equals B, then A, and then if we subtract the same amount from each side, we still have equals, and that is the subtraction property of equality. Let's move on to multiplication. The multiplication property of equality would say if A equals B, then A, and again you have B. Now if you multiply each side by the same number, you still have equality. So that is the multiplication property of equality. And the division property of equality again says if A equals B. Again, all of these pieces start out with if A equals B, then, and again for division property of equality, we can say, hey, A equals B. So then if we divide by a constant amount, the same amount, we still have equal. The substitution property of equality, again, would start with if A equals B, again, all of these start out that way. If A equals B, then B can be substituted for A. And we've used that a lot in the past. So those are our properties of equality. And then this division property of equality, we actually talked about that earlier. If you have A times B plus C, that will equal, again using the distributive property, A times B plus A times C. And the same would be true if you did it with subtraction. So A times B minus C. Now what changes is you have AB minus AC. So that is our distributive property. So here's what I'm talking about when we start to work on proofs, okay? This is our kind of introduction, and this is kind of our baby steps into it. But if we have this equation and we want to solve it, okay, our first step here, or our first statement, is going to be really just the problem we're trying to solve. And our explanation of what we did is we wrote the given problem, or right. And the reason is because that's given. That's our given task to do. Okay, so that might be a little weird to think about, but let's move on as we go forward and see if this starts to make a little bit more sense. Okay, so our next step after this is we need to use the distributive property. So our explanation is we are going to multiply -4 with the 11x and the 2. And the reason we are allowed to do that is that distributive property. And what the result would be after we multiply by negative 4 would be negative 44x minus 8 equals 80. And oftentimes we don't write that statement last, but I just wanted to show you kind of what we were doing. So now what would we do next? If we were solving this, we would be adding 8 to each side. So when we add 8 to each side, we would end up with negative 44x equals 88. So again, our explanation of how we got to that step is to add 8 to each side. And what property allowed us to add the same amount to each side? That was the addition property of equality. Okay, so now we're almost really on our last step here. And if we finish solving this, we get a value of x equals negative 2. What did we do to get x equals negative 2? We had to divide by negative 44 on each side, and that is our division property. So this is what we're talking about when we are justifying our steps in solving with the properties that allow us to do that. The explanation column is kind of a little strange. It's something we kind of do, and eventually we will probably just eliminate that explanation column as we go forward. All right, so I'll get us started on this one. Okay, so again, we start out with the given problem. So 14x plus 3 times 7 minus x, okay, equals negative 1. Okay, what did we do? We just wrote the given problem. And our reason was really that's just our given task. All right, so now what would you do next to solve? Think about it. See if you can figure out what you would do next. Well, what you're going to need to do next is the distributive property. So our reason we can do the next step is our distributive property. And what are we going to be doing to get the answer? Well, we're going to be multiplying the 3 to the 7 to get 21, and the 3 to the negative x to get negative 3x equals negative 1. So our explanation there is that we multiply 3 with the 7 and the negative x. Okay? Now, I'd like you to see if you can try finishing this question, following the same steps we did in the example previously, and kind of how I got you started. Pause the video, see if you can finish this, and then start the video and see if you got it correct. So, your next step here would be to combine like terms, and really what we're going to call that is simplify. And you might not have had a reason for that, or you could write combine like terms and that's fine, but really what we're doing is we're going to have to add the 14x and the negative 3x, which would give us 11x plus 21 equals negative 1. So then the next thing after that, we would be subtracting 21 from each side, and that is the subtraction property. And our result would be 11x equals negative 22. And so then our last step here is we are going to divide by 11, and that is our division property of equality, which gives us a value of x equals negative 2. All right, so I've given you some chances to try these problems. This is really the same thing with only variables, but it's really the same process. So we would again start with c equals 2 pi r, and again that's write the given problem, and that's given. And so now, if we want to solve this for r right here, what are we going to need to do if we want to solve this for r? Well, we're going to divide each side by 2 pi. So when we divide each side by 2 pi, we're going to get c is equal to, or c divided by 2 pi is equal to r. And so, again, what did I say we did? We divided by 2 pi on each side, And what allowed us to divide by 2 pi? Again, the division property of equality. All right, so we have a few more properties to talk about. And we can talk about something called the reflexive property. Okay, the reflexive property, how you can kind of remember it equals itself. Okay, so with numbers, okay, we would say like A equals A. Or if you want to do a specific example, that would be something like 2 equals 2. It equals itself. When we're talking about segment length, we could say that the segment AB, that length of that segment, remember the distance between points A and B is the length of that segment, that's that symbolic notation, is equal to the length of segment AB. And with angle measure, what that would look like is that the measure of angle 1 is equal to the measure of angle 1. So again, it equals itself, okay? That's what reflexive is, equals itself. Okay, so now the symmetric property, that's different. So the symmetric property, if we take a look at that, the symmetric property is sort of like the mirror image. Or it flips across the equal sign. So that can be hopefully a way you can remember it. But for numbers, it would be something like, look like this. If A equals B, then B equals A. And again, if we actually put in numbers, like if 5 equals B, and let's say B is 10 divided by 2, okay? So we know that that's true, then 10 divided by 2 equals 5. So again, it's kind of the mirror image and it flips across the equal sign. For segment length, it would look like something like this. If AB is equal to CD, then CD is equal to AB. And again, if we're talking about angle measures, we could say if the measure of angle 1 equals the measure of angle 2, then the measure of angle 2 is equal to the measure of angle 1. All right, and last property here, transitive property. The transitive property is kind of like a logic chain, okay? So that's like our logic chain. And so with numbers, it would look like if A equals B and B equals C, then A equals C. So that's our logic chain. And for segment length, we would do the similar process. If AB equals CD and CD equals EF, then AB equals EF. Transitive property of equality. And again, for angle measures, it's the same really process. It's just a matter of switching out segments for angles, etc. So this last piece would be if the measure of angle 1 equals the measure of angle 2, and the measure of angle 2 equals the measure of angle 3, then the measure of angle 1 will equal the measure of angle 3. All right, so those are our properties, and those are our beginning steps with starting to prove things or justify. We basically were proving that x equals a certain value given that beginning equation, okay? But sometimes our proofs are going to get a little bit more involved, okay? And you're not going to necessarily need to be quite this proficient with proofs at this point, but the more you can listen and watch and try proofs, the easier it will get. So I'm going to work through this proof so you can kind of see where we're going. It says, given that angle ABD is equal to CBD, prove that measure of angle EBA is equal to the measure of angle DBC. So for simplicity's sake right here, what I think I'm going to do is I'm going to change this just to that angle 1 is congruent to angle 3. And it's just going to be simpler for me to write. That's all. Because the measure of angle 1 right here is ABD. I'm just going to use 1 and 3 instead of the letters, okay? So we know that these are equal, they're congruent to each other, so that means it has equal measure, and they're marked that way as well, so it's not a mystery, okay? But I'm going to just kind of highlight that. So the first thing I'm going to say is that angle 1 is congruent to angle 3. Okay, so again, the reason I can say that is sort of given or marked in the diagram. In this case, it was given and marked in the diagram. And I really just copy or write the problem, I guess I would say. Copy or write the problem, the task that we're trying to do. So this prove thing that is at the end here, that is going to be at the end of our proof. That's going to be the last thing. We're proving that that is true. All right, so we know that the measure of angle 1 is congruent to the measure of angle 3 because they're congruent. So that's the next thing we can write. The measure of angle 1 then equals the measure of angle 3 because that is our definition of congruent angles. What are congruent angles? They're angles that have the same measure. So that's what I just said. Okay, those are kind of picky things right there. So I won't get too worked up about it. And here's where our explanations kind of get muddy. Like, well, what did I just do? Well, I just used a definition. So we're kind of going to skip this explanation part for right now, and just move on to like the statements and reasons. Okay, so now we also know that the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 2 plus the measure of angle 3. So how do I know this? Well, because all I really did was add here. If you look at the 1 and the 3, I added the measure of angle 2 to each side. And so that really is the addition property of equality that I just used. And we don't need the equality part, okay? Don't worry about that. Okay, so now I know that angle 1 plus angle 2 right here, if I highlight it maybe with a different color, angle 1 and angle 2 is equal to A, B, E. So, or EBA. So I know that the measure of angle EBA is equal to the measure of angle 1 plus the measure of angle 2. And that is our angle addition postulate. Okay, now we can do the same thing with DBC. So DBC, that angle is 1, 2, and 3 added together. So the measure of angle DBC is equal to the measure of angle 2 plus the measure of angle 3. And again, that's the same angle addition postulate. Okay? So now I have also that 1 plus 2 is EBA and 2 plus 3 is DBC. But I also know from this statement above back here, so let me go back here. Okay, I also have this. So what I can do is I can substitute what 2 plus 3 is equal to right here. Here's 2 plus 3. I can substitute what it's equal to right here in for that. Okay, and I can also, so I can put the measure of angle DBC up there. But then I can also similarly do the same thing with angle, measure of angle 1 plus 2 is equal to DB or EBA. So I can put that right here. So really what I end up with the result is I end up with taking out the measure of angle 1 plus 2 and putting the measure of angle EBA in there, taking out 2 plus 3, which is equal to DBC, the measure of angle DBC. And that was kind of double substitution. And sometimes we might substitute those in separately for clarity, or you could, because that would be fine too. So now I have actually proven what I set out to prove is that the measure of angle EBA is equal to the measure of angle DBC. And honestly, eventually, that's going to be something that you can do all completely on your own. But right now, I just wanted to kind of show you where we were at. Here's an additional one that we could also prove. And this one's probably a little bit easier. So again, I'll go through this one with you as we're just beginning to understand proofs. All right, so we are given that AB is equal to CD. That's marked in the picture. So that one of our, a lot of times our given is like our given problem or given what the task we're supposed to do. So we have AB is equal to CD, and that is the reason given, okay? And again, this is just like copy the problem. And sometimes these explanation columns, again, they're going to go away anyway, but just sometimes it adds some clarity. Okay, so now we can write that segment AC right here is equal to taking AB and BC, that equals AC. And that is adding a segment addition postulate. We're adding adjacent segments, and that is our segment addition postulate. And likewise, okay, we could do the same thing for BD. So if we look at BD right here, okay, that could be BC plus CD. So I'm going to write that BD right here is equal to BC plus CD. And again, that is our segment addition postulate. Okay, so now again, we can see that CD right here, is also equal to AB. So since these two are equal, we could use substitution now. And we could take what AB is equal to right here and substitute what AB is equal to in for AB. And that is our substitution property. And so now what we have is we have CD plus BC. Oh, sorry, I'm going back to this one, sorry, for clarity. I have CD plus BC equals AC. And so now if we take a look at, we actually have that BD now. We can prove that BD is equal to AC because we substituted okay, so we substituted, that's what we did, we substituted right here, and then we now know that AC, we could set these two equal to each other, okay? So we have AC equals this, okay? We also have AC equals this, okay? And I'm gonna do one more step in here, okay? So what that means now is since AC equals AC, we can substitute and we can say that AB plus BC is equal to CD plus BC. And so now if I subtract BC from each side, okay, now I have that AB is equal to CD. And since these are equal to each other up here, then we wind up with BD is equal to AC, and AC is equal to BD. And that's what we were trying to prove. So again, these are kind of baby steps, but we are using, in this last step, the symmetric property. So we'll walk through some more of these, and there's always more than one way to kind of go about and lay out the steps, but we're just going to I just wanted to kind of give you a feeling of some of the things that we're going to do.